My name is Matthew Lickwar. I'm a co-founder of a business called Ynomia. And we deal with IoT, specifically in construction. And so when I was asked to present today at Project Controls around innovation, it was a pretty easy solution for me to kind of come up with a topic of conversation. I think a lot of, maybe first a question for me in terms of people in the audience right now. Has anybody within their business used or utilized or experimented with any type of IoT project, or is anybody? No. So I guess the framing of my presentation was really around people that were interested in IoT, or to equip perhaps everyone with a little bit more knowledge about how to approach the design perhaps of an IoT project. Perfect, good question. That's what I wanted to get to. So one of the things that I wanted to talk about as well was simplifying the conversation. I used a term in my title called Industry 4.0, which is very common to hear, but what does that really mean? And IoT, Internet of Things. So the Internet of Things, and what really the presentation, I guess the fundamental piece that I wanted to talk about was that, we hear a lot of buzzwords, Industry 4.0 or machine learning or AI, and the constant question is, how does that apply to my work or to my business? My particular area of focus in the last 2 years, our business is on IoT, or Internet of Things, essentially connected systems that connect the physical world with the digital world. And we track essentially materials or supply chain or resources, equipment, or things within a construction site. So to frame the conversation within Industry 4.0, historically that conversation around Industry 4.0 has meant manufacturing, the digitization of manufacturing. And construction's probably left out of that in that conversation, but really you can just assume that when people talk about Internet of Things, what they're talking about is, how can I connect a piece of equipment that's in a building or in my project to a dashboard, or to the project team that's controlling or responsible for? How do I know how many pieces of equipment are on my site? How do I know how many people are on my site? What types of information? So it's very much around the problem, I guess, that you're looking to solve. But really, the fundamental piece of when anyone talks about Industry 4.0 or the Internet of Things is really about connecting physical objects with a digital piece. So connecting them, if you will, to the internet. It doesn't literally need to be a Wi-Fi or a modem like your house, but it can be a cellular connection. It can be radio frequency Wi-Fi, these types of things. So my presentation was really around framing for you folks that are probably hear these types of words and perhaps are looking or interested, or somebody within the businesses is keen to implement an IoT-based project. And I guess the way I would like to frame that really is as simple as possible. So if you do have questions, first of all, raise your hand. That's absolutely makes it a little bit easier to go forward. I wanted to simplify, I guess, the approach, and I look at this on the left is really what I'd like to do is give you 3 types of rules or a playbook, if you will, around implementing an IoT project and how to frame it. So what I've really spoken to here is around a piece of information. You're looking to capture a piece of information. So you want to connect to, I'll go through a case study here and give you a concept or an idea, I hope, of how this type of application can be utilized. So really, the 3 rules really are, the data you're looking to capture, the input, the output, so how do you get that data out? And then the third is really how you process that data and how do you serve that to make meaningful kind of concept to the people that are consuming it. So ideally, there's a target to this process. And on the right-hand side, I'll go through a case study a little bit. So we focused mostly on large construction. So buildings, not so much infrastructure, but the application can suit itself. And that is an example. The photo there is an example of one of the first projects we had tracking facade panels from a factory in China to the installation on site here in Melbourne. And so we were able to, you can see the left-hand photo is an actual image of 2 facade panels installed in the building, the first 2 facade panels of that project installed in the building. And on the right hand is essentially the tracker we used to reflect the data that we'd captured for a sensor on each facade panel that's moving through that supply chain. And why that's important, I'll kind of go through this study, or what we really kind of can gather from that. So hopefully you get a concept or an idea of how IoT can be used and how maybe it could apply to your specific business or use case. So I'm originally from the US. My parents were visiting. We were in Tasmania last week, and we were at a small shop in a town called Branxholm, which is really beautiful. Reminds me of where I come from. And the woman at the shop had a point of sale, a Stripe type device, iPad, and a card swiper, and she couldn't get it to work. And she's commented, "Technology, it's great when it works." And I kind of chuckled because I deal with construction sites and trying to implement IoT and use cases within construction every day, and it's the same thing comes up. And I think we can all probably associate ourselves to, when technology works, it's great. When it doesn't, it's really frustrating because it's supposed to save us time. And ideally, it's taking the complexity out of things. So I think framing all this entire conversation, we're talking about how do we apply technology to a process or a product, and it should simplify. And so at the end of the day, if it's not, something's not right and it needs to be fixed. And that's fundamentally, I think, a principle that it should simplify instead of creating complexity. And often we find ourselves, especially in construction, the mentality on the use case side is very difficult because technology, if it's not saving someone directly time, it can be a very frustrating process to overcome. So I think framing the conversation really is it should work, and if it's not, it needs to be corrected. So a bit about me. If you want to connect on LinkedIn, you can please feel free to just connect. My background is an engineer, a mechanical engineer. I worked in the automotive industry for over a decade, internationally, essentially setting up production and international business for a German company so we worked for BMW, for instance, building manufacturing weld lines for suspension, things like that. So that entire part of my career was about managing the flow of material to a static, let's say a fixed production line, doing the same thing with repetition. And that's hard enough. And in that, a lot of that conversation was around lean processes and principles. And that's kind of where the conversation around the lean industry came from, or at least was probably made it a topic of conversation. So my background is probably in lean manufacturing, which really means kind of constant improvement. I would just translate that to continuous improvement and ways to feedback and improve and reduce things like waste, scrap, etc. I worked for a little while for Uber, doing more static measurement, or taking a static snapshot, perhaps, of the world around it. So mapping, 3D mapping for street level, kind of like Google Street Maps. And then now my career at Ynomia, as a business we started 2 years ago, I have 2 other co-founders, is around managing the dynamic flow of construction in a dynamic environment. So now you've got a production line that's actually the people and the tools and the material coming to those people, and the production line is constantly moving, and the product is kind of staying put. So a little bit the opposite, and it's a hell of a lot more disconnected, let's say, than a manufacturing environment where you've got a factory floor and you're able to install infrastructure and you can monitor kind of what goes into that box and what goes out. Construction is a much harder environment if you're in construction than you're aware kind of the difficulties of just establishing a PowerPoint. Like, temporary power is the name of the game in most building sites. We deal specifically or mostly with vertical construction, and so that environment where you're constantly moving up the building and trying to do essentially the same thing floor after floor after floor for each trade. And so Ynomia, our business, is really around providing accurate, reliable, automated data for construction in real time. Where that matters, or why what we're really aiming is to amplify the ability to control a project through information. So providing information for time, location, and movement. So we've developed a sensor network, basically, which is the IoT part of the Internet of Things, that can be deployed continuously across a project and work without power. So it's low energy, it's battery operated, and can work for the life of the project, and can really monitor or track the location of objects within that construction site. So we've gone down a path with CSIRO, Data 61, to commercialize a piece of technology that's Bluetooth based. So we track objects using Bluetooth, low energy Bluetooth. And we also have combined that with a long range called LoRa, a long range radio frequency that allows you to put these types of devices into a construction environment. Let's take that project, a 30-story tower, and not have to put gateways or receivers of information, the things that you want to, and I'll go through. The next slide is about definitions and lexicon of this talk, but I'm probably getting ahead of myself. And so what we're able to do with this sensor technology is take out the need for PowerPoints or gateways through a site to capture information, and you create essentially a more distributed independent network. So the device on the left can listen to the tags, which are the 3 different versions on the right. Those have a range perhaps of, let's say, 40 or 50 meters. And the device on the left listens for those types of tags for location and sends that back then, and can it send information or small bits of information a kilometer, if you will. So under the right conditions. So we've got the balance of a short and a long range. So we don't need to put in gateways to collect information from all these sensors. Which leads me a little bit to here. I think this is probably an important conversation. If you're facing an IoT project or any type of technical project, it's really important probably to have or to take on the fact that you develop a language around that information, or the team, your team will, or your whoever is supplying the service. It's really important to understand those pieces, because we often use buzzwords to make it easier to relate, and the way that tends to cause confusion perhaps for some people, and it certainly makes it difficult to understand what a technical project is all about. So in this particular slide, I've kind of showed you, we use essentially a beacon, which is a fixed infrastructure node, and we put that wherever we would like to within an environment. It's small. It's kind of the size of a 50-cent piece. And the density with which you put those gives you a granularity, essentially like GPS for indoors. And so when you take a sensor or a tag, which is essentially the same piece of hardware, so we've got hardware and software we're talking about now. So hardware is like your phone. It's a physical device. It's got a computer or a chip type of thing. And software, the things that run that hardware, tell it what to do. And this is, for us, this is called an embedded system, because we're taking that cyber piece, the sensor, and putting it into the physical world, cyber physical system. So embedded systems are things where you're embedding small devices, sensors, if you will, in this case, or beacons, same type of concept, into the physical environment to interact or capture. Now, when I say gateway, so the gateway is what's actually pulling that information out of that environment. So everything has a range. We have radio frequencies we're talking about. So the radio frequency being Bluetooth or Wi-Fi, same type of thing. You have a certain transmission range. You go away from your router and you lose transmission. Same thing for Bluetooth. So in a Bluetooth, you get a range of perhaps 30 or 40 meters, roughly, depending on the environment you're in. And that gateway is listening for those different pieces, the tags, which are sending out their location, and that's backhauling it to the cloud, so essentially a database, or the processing. So we've got essentially then a stack, if you will, and this is a term that's often used in technology, is what's your technology stack. This can have many different applications, but for this conversation now, we talk about hardware, which is the capturing piece. You've got middleware, or the middle piece. People talk about the cloud. Like, this is essentially capturing information from the physical environment, backhauling it through a gateway and sending it to the cloud or to a database, where that database can then process. So when we talk about data analytics or processing, essentially you've captured physical information from a sensor. That sensor has transmitted it to a gateway. That gateway is connected to the cloud through perhaps LTE or Wi-Fi or a local area, a cable, an Ethernet cable. And then it's being stored in a database somewhere. So a store of information, which can then be processed. And that middleware is then what kind of does the analytics and then feeds it up to your application layer, which is what we generally assume an app on a phone is kind of your interface to information. And so the same concept applies here to IoT, really, is that you're pulling information out of the environment and you're serving it to somebody with meaning in an application. Any questions on that so far? Does that make sense? So going back to what I guess I wanted to frame the conversation, at least for you, the playbook. The first piece around setting up an IoT project is really what do you want to capture? And I think that this is probably, I put 50% up there. It's, again, this is my perspective in my world. This is, take it with a grain of salt. You want to spend about 50% of your time really framing the project and understanding what it is you're trying to capture. The question really here is, what information do you need? So this is the heaviest slide in terms of words, or it will be in a second. And that first phase is really about understanding your problem, but on a very deep level, from all angles, I would say. And I'm going to present a little bit of a case study to give a bit of context then to the work that I'm proposing. So in this phase, you're really questioning and discovering, what is it? What is your problem? What is it that you want to capture? What is the area that you're looking to attach your IoT devices or your Internet of Things? If you're, in our case study, it's really the facade panels on that building. Those facade panels get manufactured in a factory in China, and they are, they're high value. It's what we call, from a product perspective, high value material tracking. That's a Ynomia term, HVMT. And so it's high value because for a construction project that's occurring in Melbourne CBD, you've got facade panels that are being manufactured in China. They are individually quite high value, $4,000 or $5,000 perhaps per panel. They go for the length of the project because they're not all manufactured at once. And they're critical because they enclose the building as it goes up. And it means that safety and weather is a much easier factor. You're locking out weather. You can do the work in behind those facade panels. So for a general contractor, this is a very important project package in their project because there's a huge amount of risk. It allows all the other trades behind that facade to do the work that they need to do in a safe environment. And so when it's coming from China, one of the things that we identified was that from a business standpoint of view, it's really hard always to go down to the cost details and get costs. But when you talk about risk or risk avoidance, the ability to know within weeks or weeks more of time that you can react to an issue in production happening in your manufacturer in China or in your supply chain can mean a huge amount to a building, liquidated damages. So getting visibility upstream of that production process that was before was just maybe arriving at their warehouse in Melbourne. And now we're looking at their factory and being able to see how many pieces are being produced a day. So these are kind of the things that you can do with IoT. So going through this questioning phase is really, it's not just, we have a problem, it's also understanding all that problem. And, in this particular case study, I'll go through the difficulties with that, but you've got a supplier, you've got a customer, a contractor, you've got other people involved, and perhaps there's multiple stakeholders within that particular process that you're trying to track or capture information from. Or it could be just as simple as you've got a piece of equipment in the field that you want to attach a sensor to know when it's running. And it's far away and it's costly to send somebody out there. It can be as simple as that. So I think framing the project of what you really want to do within an IoT environment and capturing that information, you really need to know ahead of time. These are the questions that kind of came to mind when I was first thinking about this. And what data at which point takes away the pain. So, framing the conversation or framing the picture, because ultimately you're probably not implementing your own IoT solution. You're coming to somebody like my business or somebody else that's specialized or focused in this. And you really want to be prepared to ask them the questions and understand the process. But ultimately, it's your process and project. So if you are ever implementing an IoT project, I would say don't expect myself or somebody else to come in and know everything. If you really understand the problem you're trying to solve, it's going to have huge benefits in the long run in terms of not only being able to define the criteria of success for you and your business, but also taking out perhaps the cost or pain of going through that process with somebody else. I would just say don't expect them to know everything. That being said, we spend a lot of time figuring out use cases in construction and how to make those work, because it's a very complicated process with a lot of variables. So as I guess your business well, and that has value. Who owns that problem, the problem and solution? Because you've got people you've got executives, you've got different layers of operations. Perhaps in construction, you've got general contractors that have a site manager, a project manager, project coordinators. You've got suppliers or material suppliers to them. You've got subcontractors. There's depending on, knowing all those stakeholders and who's actually interacting with that information, or who's controlling that problem, or where that problem is, and who's going to drive the solution, and how many people you need around the table to get that solution done in an effective way. It's common sense, I suppose, but it's a lot of work to answer those questions. Also, organizational mentality. We work in construction. It's not known for its innovation necessarily all the time. At least that's the way the jokes go. So when you're working with trades on the 40th floor and you're trying to understand how they're going to interact with an app, or how they're going to offboard the sensor that's attached to that facade panel, it becomes important. And then I guess the final thing I would say, there's a concept from Lean in my automotive experience called Genshi Gebutsu, which is a Japanese word where the Lean kind of process materialize or crystallize, but it means look and go see. I think often, in my work, often it's developing an IoT solution in construction. I spend a lot of time on construction sites figuring out why things need to be where they are. And so designing your process really comes down to knowing intimately the entire scope of the problem. So we're tracking facade panels, like I said, from China. Oops. And the existing tracking method was Excel. So they used an Excel sheet that was going back and forth between their Chinese supplier and the project team here to track and fill in boxes. Each one of those little colored boxes was a facade panel, and depict status and figure out, what status was something in. Now that's a manual process. It requires your counterpart to update that. You've got a static issue with, the timeliness of that data. Is it correct? There's no way to know. And so that's why I think understanding, for us, when we initially approached this, we thought, it's about trying to find the best automated way to capture that data and present it back in an automated way to fill in a box in colored square. And when you come down to it, it's a lot more than that. It's like I said, it's about risk avoidance. So identifying notifications that you can send to the project coordinator based off a certain level of information, a production rate in China. So there's a lot more things that you can do with that. So I would expect that understanding understanding the entire scope of the use case, and the expectations, I suppose, of all the people involved with that project. And understanding as well the technical limitations of the devices that you want to use or implement. So we're tracking facade panels with attaching them through an app on the phone you see in the right there. Those little tags, if you will, transmit a certain range. So knowing the process that's going on and where they're going through the supply chain became about knowing the critical factors that we wanted to monitor and the range that those tags would be heard. So there are limitations, I suppose. I guess the point there is, the implementation of devices, everything has a technical limitation. It's physics. And so knowing the limitations of your problem and knowing the limitations of the product that's trying to solve that become important to the reliability of that. And ultimately, I guess this whole phase, what we're talking about is the input phase, or capturing information. I think it's really important to frame this part of it to say, once you've gone through that problem and identified the process, you're looking for somebody that's going to be able to help solve that problem. And that could be a supplier search. It could be going down that process. But you should have a plan around what are the main things you want to test, and being able to test those assumptions and develop smaller projects. So POC, or proof of concept, would be a concept that somebody in technology world is very familiar with, because you're not just going to roll this type of solution out to every project or every location you have in your business. It could just be one. You want to prove value small at first, and then take that, or at least have a plan to scale that out to the broader business, perhaps. And I think the other aspect probably for IoT that's important too, or that you should be asking, is, are you trying to reduce waste, or are you creating a new business model? And that's kind of the basis of IoT in general, is that you can use it in many different ways. It really depends on, it's either opening up a new opportunity, or it's helping you to improve an existing opportunity. So when we identified our process of the supply chain of tracking facade panels, we realized what was critical to our contractor was being able to see further upfield. So they were on site, they knew what was in the warehouse, but now could we kind of give them a visibility of the entire supply chain from the production floor in China? So we basically segregated the entire supply chain. So starting in China, it was this created, so the concept of attaching a sensor to a facade panel, and we did that through a mobile app. Second stage would be then manufacture complete. So when that particular facade panel came to the end of the production line. The third stage that mattered to them was then, when is it actually on its way to me? And the fourth stage is then arrival to site. So when it arrived to site. And the fourth then installed, or fifth, I should say. So being able to track all those pieces of the project, we did that with attaching a sensor to a facade panel. And the first stage and the second stage were both done with a mobile phone or an application, and all those other stages were done then through a gateway. So through that facade panel and that sensor going by a gateway stationed at those particular critical points in the project. So the second component to this entire, I guess, playbook, if you will, was really around the output. So you've defined the scope of your project. You really wanted to, you figured out the problem, you figured out your supplier and your solution, and how that's going to happen, who's going to be able to help bring your IoT project to life. The second stage is about capturing it, or actually implementing that. And I would say that, that could be 25 to 35% of the project. That's an approximation. Again, it depends on the size of the project, but, just kind of where you should focus your effort, 50% on planning, 25% on really capturing and making that solution work. Ideally, that's a smaller percentage if you've done the right amount of work in the first stage. And this question is really around, how do we collect it? So those gateways I talked about. Now, you can imagine for our case study, putting up gateways across a factory in China and a site in Melbourne, or in the warehouse where those facade panels are first stored and they're unpacked from containers, is quite difficult. You've got all these different distributed kind of gateways. You've got to find power. I found this photo when I was going through and preparing the presentation of, when I was first on site, trying to figure out where the gateway was going to go and where the power was going to be. So that's the kind of level that you're trying to figure out, and what actually captures that information. And the second photo there is actually in China at a factory, hanging the gateway up on the top at the end of the production line, where it's able to receive that information out. So really, this kind of the piece that connects all these Internet of Things, the backhauls, it's a system, and you need to kind of be able to say, where can I get that connectivity? Especially, am I able to control all those environments? Is it, how disconnected is it? Setting up a gateway in China is a little bit tougher. So sizing or scoping the project or the IoT solution that you want is also a lot about kind of knowing how much data you want to capture, the frequency of that data, the quantity of that data, how often is it, how timely do you need it? Does it need to be every minute? Does it need to be every hour? Does it matter? Because that will define really the size of the solution and how you implement that. If you only need a certain piece of signal per day, then it makes it a lot easier than if you need to know consistently where that is. So the concept of the internet piece is really, it's very much dependent on this type of technology and solution you provide. But for us, again, remember, it's a factor of that connectivity piece. So that sensor can only transmit 50 meters. If I want to know where it is, I need to have a gateway that's collecting that information that's at least within 50 meters of where it matters. And what helps in the process, or any process really, is fixed. If there's variation, it can go anywhere. You need to cover the entire MCG with gateways. It's not really a valid or viable solution. So the distance that you can transmit and the consistency of where those pieces flow through that process becomes a critical factor to this particular solution that I'm demonstrating. But in any case, you kind of need to be able to know that distance of communication, because Internet of Things, especially with low-powered devices, they're low power for a reason. If you can plug everything in, you're going to be able to transmit at the maximum power with an antenna. You're going to be able to send or receive information with the most distance. If you've got a small battery-powered sensor, you're going to be limited by the time that you need that sensor to be alive or active and the range that it's actually able to transmit. And again, every radio frequency has a different transmission. So when we talk about IoT, it's very important you kind of know the distance you need to capture or capture to a network. And so the cost to get it is a huge factor with any IoT. And so I'm assuming again that you're probably finding a solution provider that's sitting there providing being able to assess your problem and being able to give you a solution, whether it's the devices, the hardware, the ability to capture that data. They should really be able to give you the information or see that problem. So when you're identifying a solution provider, you should really be looking at that they work in that industry or environment, that they've had experience in the environment you work, because the last mile is really the critical one. The area that you work or the area that you need to capture that data, you need somebody that understands that, because some IoT platforms, if you go out and you search for IoT platform from Google, you'll find a lot of people that just provide the service, that hardware piece and that cloud piece, but they don't necessarily know the application. They don't know your business. And so it's really important to understand if they know the environment you work in, your industry or the areas you work in, and they can do that. So for us, the focus on construction, you really want to be able to validate that. And then I guess the other thing is, from that radio frequency or that capture piece I talked about, knowing what network and the things they use to capture that information. Is it a private or a public network? Where is your data or your information going? So going back to what the case study I was trying to demonstrate before, we attached gateways for all those automated positions, so we had to put in a number of gateways in the factory in China, and that sensor, as it moved through that process, was heard by those gateways and would trigger essentially that status. And that's how we process that information. So the first 3 stages were in China, and each one of those stages was then triggered by a facade panel achieving that gateway. So from onboarding, when the panel was first being created, to the end of the manufacturing line, hitting a gateway, and that information being served up to the cloud, backhauled to our server, to shipped, to arrival to site, and then again, we use a physical means to actually take that sensor off that facade panel when it's being put into the wall, capture it, and then actually recycle it. So we capture those tags every 2 weeks from the site, and we send them back to the manufacturer in China, and they put them on again. So when a factory or that process has 5,000 facade panels for an entire project, we were able to measure the supply chain and say, well, we could probably cover that with 1,500 sensors. And so not every facade panel needs a sensor. You save costs that way. So measuring, again, the size or scope of your solution, figuring out ways that you can just say, well, I can put 200 tags in a box and send them back to China for $150 Australian, and I buy the tags themselves for $15 or $20, and it makes, if they're the number of use cases, the unit economics, it can decrease the cost of implementation dramatically if you can continually use these types of systems. And I guess the third piece was then, so you've designed a project, you've figured out how you're going to capture that information, and then it's about how you use that information and serve it up. And this is very much the application piece. It's very much user specific. It really depends on the answer to the question that you posed in the beginning, which is, how do you solve this problem and who's going to use that data? That visualization piece is always a hard question because it's very specific to your use case. It's very specific to the information that you're trying to capture and who you're trying to serve it to. So enabling people to make decisions with the information becomes around the clarity of that information and how they're able to see it and access it. And then the second piece of that is also then, how does it affect an operational level on a day-to-day basis, and how do you save money? But then, can it be used for new things later? Can you go back and test your assumptions from the beginning of a tendering phase and say, now I actually have the data from an entire project or process, and I actually can say, well, it took us this long, or lead time was average this time to manufacture, or it took, this long to ship, and change the way you cost that business. And so for us, how we viewed that was a couple of different ways we experimented with that, but capturing that information first in a 3D model to try to demonstrate kind of a usability or flow. So you can see the building, you can see kind of each one of those facade panels, and the color coding is then where it is in that process and the quantity. And being able to give that then to the project coordinator kind of means they get to see the patterns of what's happening and start detecting anomalies. And then we also experimented with a little bit more information to try to give them a bit more granularity on what's happening in that facility in China. Trying to be able to equip the conversation they're having and be able to, like I said before, the biggest thing for them was cost avoidance. So can they see ahead of time that there are issues in the factory, or that the supply chain is going to be diminished? And so, I guess tying all those pieces back, what information do we need? How do we capture it? And then how do we visualize it? And that would kind of summarize essentially an IoT project, at least the scoping and the way that we approach it. And then ideally, as I said before, this is a demonstration or initial proof of concept. What you should really be identifying is what are the key assumptions and how do we improve those later? And did we hit the mark? Like I said, technology, it's great when it works. If it's not working, we either have the wrong solution or we just didn't implement it the right way. So that's a hard question to answer, but I think you'll have an intuition when you've gone down that loop. Anyway, that was my presentation. I hope that was... Any questions or? Sure.
I had a similar building in Adelaide, with Ynomia. I don't know if that's the same company, and making those facade panels. And we were using Excel spreadsheets, and we could never work out when they were coming. So this looks like the way to do. But they made the panels, the structural steels made in one factory, and the aluminium made in another factory. And I was always worried that something like that, you might lose all those sensors, they get damaged, and then you've lost the panel, as it were.
Yeah, in this particular use case, it's a good question. There's a lot of consideration. I tried to, I guess, present a high-level view of a lot of this. There's, on that detailed piece, there's a lot of little questions. It's like exactly that. Where do you put a sensor? How do you maintain that it's going to survive through the entire shipping process and through, multiple handlings, et cetera? So that goes to kind of that first point I was making around, knowing the entire process and that you're trying to capture. Like, where are those sensors going to be? Where are they? What are they attached to? And what's the life of that sensor life? Experiencing that or going through those questions is certainly important.
So my question. Okay. So my question is an extension of yours. Actually, it's how did you commercialize that with the Chinese contractor? And the second thing is that there's probably another part of that is, did you have any natural attrition of your devices? Things falling off?
Yeah, that's two very good questions. As I mentioned, I didn't go too deep into, I tried to stay as high level as possible to give an overview, but I think that what I mentioned in the first part of scoping that project, a lot of it's around the relationship. So you've got a general contractor that's giving a package of this facade to a Chinese supplier. So for us, going to a contractor, the earlier you are in construction and a tendering phase, if you're in that tendering phase and you will use Ynomia to track your facade, it's very easy. If you're going in and the general contractor is just enforcing it, but it's not contractual, maybe you have an issue. But yeah, it's not always that easy. Ideally for us, getting into that, we have multiple clusters. We could benefit the facade manufacturer and supply to them so that they can track their process, or we can actually, for the general contractor in this case, we did the same. So I think, the nice thing about this is what we actually create is a shared ecosystem of information. The supplier has information, they know what's actually being done. The general contractor has information, they know it's being done. It changes the conversation, this type of information. So if you open it up and you're not, a shared information platform, especially in these types of distributed systems, makes a huge benefit to overall decision and conversation. And you had a second question. The sensors, yeah. Every technology application, you kind of assume that there's going to be a human factor, and there's going to be some that we've had some sensors that get taken off at the site. People just kind of, what's that? They want to take that off, or they're interested in inspecting it. There is a natural attrition. I don't think you can assume that anything's going to be 100%, and that's again factoring into your value pieces. Can you ensure that you get enough percentage that it drives value or makes, adds benefit? Yeah. Thank you.